The data and analysis that follow were generated by AI in April of 2026. Everything about this analysis can and will change. Check in regularly with AI organizations, GIS companies, and federal or nonprofits to track the movement of the labor market in this sector or any other that you are interested in. Artificial intelligence is already reshaping entry-level geographic information systems work, but the impact is more about changing tasks than eliminating careers. A realistic estimate for 2026 is that AI can already perform or significantly accelerate about 20 to 35% of the tasks commonly assigned to new GIS technicians, especially repetitive work such as data cleaning, geocoding, metadata writing, simple map production, first draft reports, and basic scripting. Looking ahead 5 years to 2031, the most defensible estimate is that AI could handle 30 to 55% of today's entry-level GIS workload with a midpoint near 45%. By 2036, or roughly 10 years out, AI could likely complete 60 to 80% of the tasks associated with a 2026 junior GIS role, with a midpoint around 70%. Reaching near total automation is slower because the last portion of work involves ambiguity, stakeholder communication, judgment, and data quality problems. The most plausible window for AI to perform 95% of the tasks commonly associated with 2026 entry-level GIS technicians is 2042 to 2048, with 2045 as a practical midpoint estimate. The best available evidence across technology markets suggests that jobs are rarely erased in a straight line. Instead, they are redesigned. GIS is likely to follow the same pattern. Traditional entry-level positions focused on digitizing, routine editing, static map production, and repetitive database updates will likely shrink. However, demand should remain strong for people who can supervise AI workflows, validate outputs, and communicate findings. In other words, employers will increasingly hire fewer button-click GIS technicians and more hybrid analysts who can combine GIS with automation, analytics, and domain expertise. Many organizations in government, utilities, transportation, environmental consulting, logistics, defense, insurance, and urban planning still need trusted humans to interpret results, understand regulations, and make decisions. For college students studying GIS today, the smartest move is to stop thinking of GIS as a standalone software career and instead treat it as the center of a larger technical toolkit. Students should absolutely master core GIS concepts first: projections, coordinate systems, vector and raster analysis, geodatabases, and cartography. To compete against both AI and other applicants, students should pair GIS with Python for automation, SQL and PostGIS for enterprise databases, and strong spreadsheet and data wrangling skills. They should learn how to use AI tools to generate scripts, summarize reports, create prototypes, troubleshoot workflows, and accelerate repetitive tasks. Knowing how to direct AI productively will be more valuable than resisting it. Students should also build experience with modern GIS workflows rather than older desktop-only patterns. That includes web GIS, dashboards, APIs, cloud-hosted data, and mobile field collection. Familiarity with Esri platforms such as ArcGIS Online, ArcGIS Pro, QGIS, and open-source Python libraries like GeoPandas will help students remain flexible. Learning remote sensing tools, drone imagery processing, GPS data capture, and imagery classification can create additional advantage because spatial imagery is a fast-growing field where GIS and AI naturally overlap. The strongest candidates in the next decade will also pair GIS with a knowledge domain. Employers hire people who understand an industry problem, not just software menus. High-value pairings include GIS plus environmental science, emergency management, public health, urban planning, real estate, logistics, agriculture, or defense intelligence. A graduate who understands stormwater systems, electric networks, wildfire planning, land records, or supply chains will often beat a candidate who only knows GIS software. Finally, students should develop communication and portfolio strength. They need to explain what a map means, what decision it supports, what uncertainty exists, and what value it created. A GitHub portfolio, dashboards, automation scripts, and real project case studies may matter more than grades alone. The bottom line is clear: GIS remains a strong field, but the safest path is no longer learn GIS software. The safest path is become a spatial problem solver who uses GIS code, AI, and domain expertise better than anyone else. What do you think? Do you agree or disagree with the AI's career forecast for entry-level GIS technicians?